Thank you very much, Wayne. Hello, my name is Campy, and 10 years ago, some of us at the Special Interest Group were lamenting the lack of robot building activity in the club. And, we noticed that activity coincided with contests that we were doing, line following, maze busting, that kind of thing. But when you had the contests, it's like somebody was always not happy. They used a shinier tape, or their walls weren't quite as wide, or just something. And we knew we had a lot of robots in the club, but we wanted to do something that didn't have any setup. You know, you didn't have to haul the stage around. We met at a library at the time, the Castro Institute Library in Campbell, and there were tables all around, so we thought, tabletop soccer, let's do that. Well, okay, we're going to put nets around it, you know, to catch the robot in case it falls. But wait a minute, that would be set up. And so that's when it was born, the TableBot. A TableBot is a robot designed to survive, live, and play on a table, or pay the price. And how do you get to tabletop soccer? Well, the same way you eat an elephant, one bite at a time. So we decided to do phases, and in June that year we did phase one, which is basically go from one end of the table to the other and back. Phase two is to push a block off the edge of the table, and then phase three is to move the block into a shoebox mounted at the end of the table. And for the past 10 years, we've done phase 1, 2, and 3 in June, August, and October. And in addition to that, we've just opened it up to the HBRC challenge, where the concept is, you know, you bring your robot to some state of finish in June and say what you're going to do for the next two phases, and then we track that. Now that hasn't worked out at all, okay? Typically, everybody, you know, puts something together at the last minute, you know, the day before, that kind of thing. We've come up with some really amazing things done in a short period of time. Personally, I perform best with a deadline breathing down my back. Anyways, so this is the club bug. And it's an Arduino with a couple of servos. I'll go ahead and switch him on and get him bouncing around the table. Let me get the goals set up here. Again, with the TableBot challenge, we don't specify the robot size. We don't specify the table, the color, the size of the box. I see some awfully big shoe boxes out there. But it's all about the show. It's all about showing your robot in its best light. Now here's my goal here, all right? And we've got 50 new blocks. This is henceforth the official block now from Unbounded Robotics, right? There we go, Stephen. Okay. So here's the block, and let's see how we do here. Yes, yes, yes. Sweet, sweet. Oh, beautiful dance. That's phase 3, ladies and gentlemen. Okay. Do we have any other TableBots out here? Raise your hand. Okay, Marcus. All right, come on up. Phase 1, 2, or 3?
1.
Phase 1. Marcus, what's your robot's name?
My robot's name is ShieldBot. I got this at the Maker Fair in a kit, but me and my dad, right there, we've sort of adapted to it. We've added this sensor. It used to, this sonic sensor used to make this LED light flash the closer something was to it, but with all that programming, for some reason the servos didn't move, so we had to get rid of that. So now all it does is go from one end to the table to the other, but sometimes the table calibration screws it up and it ends up going this way. So here it goes.
What could possibly go wrong?
Exactly. But it's never fallen off once.
I wouldn't say that. Not out loud.
1. Take 2. Gone. Okay, 2.
I'll be good for
Get better now.
A little curve on it. Yeah. It's a turn crossbar.
Put it on the side.
Point it like that direction. Yeah.
Woohoo!
There you go.
take a block. Yay. How about that, ladies and gentlemen? Marquez and his mother. Test 1, 2. Okay. Any more TableBots out there? Come on, we got, okay, no more TableBots. Okay, we're going to do now something called Run What You Wrong. This is the catch-all category, okay? And Gopi, what do you got there?
Arduino control the robot.
Come up and tell us about your robot.
Thanks for putting me on the spot.
And your son. Father-son team here, ladies and gentlemen.
So I wanted to build a simple robot. So we have a phone that was hacked up to connect the serial port of the phone to an Arduino. And let me turn this on. And it should move, but it doesn't have any sensors, as you can see, so it'd be a disaster if I put it on the table. So
You don't have to let it fall.
okay, so
All right, it moves.
my next phase is to connect another phone to that phone wirelessly, so I can control it from another phone. What's yours? Go ahead. What is it? Okay, so this is my son Tarun. He built this robot using Legos, and he's going to talk about it.
What does it do?
What does it do? Can you show?
It moves.
You want to put it down?
All right. That's awesome. All right, thank you very much. Who's next? Come on up. Are we having fun yet? Yeah. Awesome. Here's going to start wiring people up. That awesome wired up. What's your name?
My name's Amal.
Let's use this instead.
Amal, what's your robot's name?
It just,
Amateurs.
I don't have a proper name for the SumoBot, but it's a SumoBot. So, I have two twin Parallax SumoBots. All the parts are from Parallax.
You want to put two tables together?
Okay.
I'm afraid it's going to fall off one.
Okay, so the SumoBots are run by a basic stand microcontroller. These SumoBots have 2 IR sensors and 2 line sensors, and they also have, each of them has 2 servos and and they come with a bunch of LEDs and a couple of piezo speakers. So I wrote a bunch of code for so I wrote some code for these SumoBots, and they're supposedly going to fight. So, yeah. Okay, it should start.
Okay, so this TableBot is lost because it went out the ring, so it stopped moving. So basically that's the code. What it's supposed to do is there are sensors that are supposed to track each of the TableBots and calculate its previous position, and it's supposed to rapidly accelerate towards that position, and hopefully it'll try to knock the other TableBot out of the ring as it has done here. So that's my bot.
Did you run it?
Yeah, just need to run it. I'll run it again.
Run it again.
Are they both running the same code?
Yeah, they're both running the same code, but I made some adjustments to one of them so it'll win.
No wagering. That's awesome.
Did the right one win?
The right one.
What are you gonna do? Take a block. Take a block. All right, who's next? Come on up, Shiloh. What you got? She has a LiDAR hat.
So this is my science fair project. It's been in the works for a while, and I have a prototype. It's a hat-based navigational aid for blind, and it has a LiDAR from SB11, and it has 12 buzzer motors inside the hat band to alert the user to the presence of obstacles. So if there's an obstacle nearby, then the buzzer closest to it will go off. And it's not really a robot, but I brought it here because I need to test it on some people. So if you're interested in helping me test it, then you can stop by over there during random access. And I have a test plan I need to follow as well as some release forms to sign so that I'm in compliance with the science field rules because they're very strict. And it'll take about 15 minutes, so please stop by. I need people.
You talking about the science fair?
No, just stop by to test.
Oh, okay. Oh, test it. Did you put the hat on?
Sure.
Does it spin? All right. That's some bad hat, Shiloh. Great stuff. Only at the homebrew club.
Thank you.
That's wonderful. Yeah. LiDAR courtesy of Brew Robotics. Okay, who's next?
Let's let you go.
Ingolf has some hysterical hardware here. Here, you want this?
Good evening, I'm Ingolf Sandman. I've been a member of this club, I think, by 8 years or so, and I met him first. As Wayne said, the Homebrew Computer Club, this is the predecessor of this club, will celebrate 40 years Christmas computing. They started 74, and this was the time of Atari, Commodore, and a bit later Apple, Steve Jobs, and it became a pretty big success. So it started as the Homebrew Computer Club in 74. I lived in Germany, and I think that was the wrong place. Otherwise, I would have participated in this exciting development. But I was on my own, and in 72, I built this. This is my first homebrew computer, 72. That's before Apple, and that's before Atari. And it is before microcomputers. This does not have a microcomputer. It is before RAMs. scene was shift register. So if you move data around and you have to pick them out. The Arduino, the arithmetic logic unit, was a 1-bit unit built from EDL gates from AND and ORs. And everything is here. This computer was operational in '72, and I can show it to you. So parts, you can open it, and there are a bunch of lamps and buttons. LEDs were too expensive at that time. Here is my read-only memory as a bootstrap lowdown. It consists of dials, and the dials were read out on pulses. And this is the programming board. This thing was inspired by PDP-8. At that time, all scientists had access to PDP-8s, and the most important thing, of course, was the lunar lander. Everybody played lunar lander for hours, and everybody wanted to have his own PDP-8. So this is why I did this. And it has the instructions that all PDP-8. So and they are encoded in this keyboard. There is a complement, shift, set, link, increment, on link, of course the tag, the to complement addition, the DCA, decrement, and so on, and an end. And it was really functional. You could play music and do simple additions. So this was before Apple. And what Apple said, before Apple, the computers had push buttons and LEDs. And after Apple, or it was Apple, everybody had a real keyboard and a monitor. This was a real big step. I was not smart enough to do that at that time, so this has then if you want, please have a look at this a little bit later. I want to finish with some scary remarks. So this is about 40 years ago. I did it in '72 in the tradition of PDP-8. And a few more years, maybe in 5 years, this is 2020 or so, computers will be smarter than they are already better than mathematics. Calculus is better than the computer. They are better driving cars. The Google cars going around here have less accidents and they are more efficient. Chess playing is better done by computers. Jeopardy was won by a computer. Soon we will have medical doctors implementing computers and they will be much better. So in 5 years it will be even better, and maybe even we can replace the political guys in Washington by having it should make it much better. So there is hope. Thank you.
Genuine, this is a homebrew computer. This is the origin of it all. Thank you very much, Paul. That was great. What you got, Chris? Bring it on up. Okay. Okay. And this is Walk Like a Man. Chris, what's your last name? Mayor, there you are, ladies and gentlemen. The DARPA challenge this year year is a event
Testing,
where
1, 2,
we're trying to get a
3.
humanoid robot to traverse rubble, drive a car, use power tools, climb a ladder.
Eventually. Yeah, my name
All
is
your fondest dreams will come true.
Hopefully. Yeah, I'm Chris Mayer, and I'm one of the main members of Team Walk on Command, part of the DARPA Challenge. We were going to have Watson here today, but we have a deadline to get the video done by tomorrow, and we haven't finished the video. That's Watson walking over bricks, through a door, and turning valves.
Wow.
So hopefully Dan is home right now filming it.
And Albert, ladies and gentlemen.
Albert. I actually have a couple of pictures of Watson. We completely rebuilt him from when you see him last month. Higher torque servos, but unfortunately we blew 2 of his knees out and just got replacements yesterday. So that's why we couldn't do the video at the time. Let me quick.
How to win the DARPA Robotic Challenge.
Yeah. So to get help with the DARPA Challenge, I realized just 2 people couldn't do it alone. So I started a meetup group, Bay Area by TableBot. Just for curious, anybody here a member? Just signed up? I think they're all busy working on Watson trying to get this video done. And the idea was to get a bunch of other people who are interested in bipeds to come and help us. And we do need help, everything from mechanics, electronics, and software. And I came up with the idea to build, basically what started out as what was going to be the software development kit. Rather than everybody trying to get time on the big robot, let's build a bunch of little robots that kind of act the same way as the big robot. And that way everybody can build one, everybody can have one, and you can play with it and program it. So this is the first version. Basically it's 3D printed parts, really lightweight aluminum tubing, and we came up with a design that's very flexible, and you can reconfigure this within seconds. And we built bipeds, quad walkers, snakes, and you can just reconfigure it. And basically it's a Lego kit now for robotics. We came across these great servos, 417 ounce inches, and it only weighs 64 grams. So this thing can lift itself at the end of a 2-foot lever, which is pretty cool because he has the power to do things like lift up a can of Coke, hopefully turn a door, and push through it. So I'll show you a couple of pictures really quick. He's not powered right now, he's power tethered. If you want to see him powered up, we can do that afterward. However, I reconfigured him and I don't know where 1500 microseconds is, so when you power him up, he tends to twitch into a weird contorted position. That's how I can quickly put him into a normal position. So here's a couple of pictures. This was when we were just playing around with the quad walker. Just wanted to verify that we could get something that's 3 feet tall that can walk with these simple hockey servos, and we had a lot of fun with that. This is just get up close. So basically it's just 4 of these 2 degree of freedom joints with knees. Once we had the parts together, we threw that together. It took us about 5 minutes. Now the problem is, we have software to control them, but we don't have animation data. So when people ask, what does it do? I have to say, well, right now, nothing. What can it do? Pretty much anything, as long as you have the right animation data. So right now, we're in the middle of building up the library. Mostly for the DARPA Challenge, of course, that's walking over rubble, through doors, turning valves, things that are going to be required. But hopefully I'm going to have this guy picking up my socks within a couple weeks and pick them out to me. This is the new redesign of Watson's lower body. We replaced the pulleys and the old, I don't remember what the old servos were, but they only had like 600 ounces. We were facing one of these large Fortis 3,200 ounce servos. With bipeds, it's all about torque, and more torque. You can never get enough power. And this is sufficient for this guy to walk and do everything that he needs to do. He can lift himself, he can lift objects. So we finally got a design and a servo that'll get us to where we want to be. That's pretty much it. So I encourage if anybody wants to build one of these yourselves, they're cheap to build. And we can use people, as many people as we can, playing with these and building up an animation database and building your own robot.
Chris Mayer with Team Walk Like a Man. Thank you very much. Folks, get involved in this stuff. Opportunity looks an awful lot like work. Okay, where are we? Who's next? Come on up, Maxim. Looks like a computer-controlled Roomba.
Before we had a notebook, Aces notebook, and we were running this program that will allow the Roomba to run. And that worked, but it didn't work. It doesn't work on Crouton, which is Ubuntu, kind of a version of Ubuntu over Chrome OS. So the iron robot cable the computer wasn't seeing the robot, so I made a cable, this cable with, this is a mouse, the size of the mouse, and this is a chip that, and so now it works, but unfortunately the battery is dead, so I don't have any, I can't tell you anything, but it was working.
That's why we make videos, Maxim. We believe you, we believe you. All right, classic low battery. Thank you very much. Okay, who's next? Pat, come on up. Have you been to the club before? Okay, very fine. There you go. What's your name?
My name's Chris.
We're at the first.
Okay. This is my first robot. This is a line following robot. And let's see. You can follow a dark line on a light surface or a light line on a dark surface.
Does that have a name?
It does not have a name yet. Okay, one second. Of course. The only thing that could go wrong went wrong.
Love the Tupperware chassis, classic homebrew.
Well, I thought the design is based on a robot building for beginners by David Cook. And it's good introduction to electronics as well.
Chris, right?
Yeah.
It's Chris, right?
Yeah. That's it.
That's Chris and his line following Tupperware robot. Thank you very much. Patrick. Oh, are you going to do FloorBot? Are you going to do FloorBot? Okay, well, hang on a second, I'll already do that. I think you may be the only one doing FloorBot this evening. Do we have anybody else doing the FloorBot challenge this evening? Chuck? Awesome! Chuck's first meeting, and he's going to participate in the FloorBot challenge. That's awesome. Okay, who's next? All right, I gotta get my. Are there any more robots out there? Alan, come on up, please. Alan Downing with PR2 Lights arms.
Okay, so I work on PR2 Lite. It's designed to be a very low-end PR2. It's got a Connect, 2 LiDARs, mobile base, 2 arms. The last time we showed it off was at Maker Faire, where we took on Michael Ferguson and Maxwell, and he kicked on bot in chess. The key problem that we had with PR2 Lite was its arms were AX12 based, and it couldn't handle the temperatures got too high on when doing movements over 20 or 30 seconds. So one time it was trying to move the king's pawn. Instead, it picked up the king and then dropped it off the table and resigned in the first move. So we decided to upgrade the arm and the software and some other things. So this is the revised arm. It was designed by my son. We placed the AX12s with MX64s to swivel here. MX64s, so you swivel there. MX106s here and here. And this is a Velo gripper designed by Willow Garage. It's an under-actuated gripper that can pick up all sorts of weird shapes just by pulling this one wire down there, and it rotates there. So anyway, we're upgrading PR2 Lite in a whole bunch of ways, and if this sounds interesting to you, we work on it on weekends and free months, so come by and chat.
All right, thank you very much, Alan. PR2 Lite, ladies and gentlemen. All right. Let's see now. Are there any FloorBots out there besides Patrick's? Dillo, do you have anything?
Yeah, give me 5 minutes.
All right. Anybody that's got something to set them up now. Let's see. Yeah, there you go. Chuck and. So this is a robot that I built some years ago. It's my Brew Robot, and it's very adaptable. We just topped out the rivets and added servos and a little ultrasonic detector, and he moves around. Used to put a heart in, you close the door and you say, hello, you were my friend, looks like I move the speaker up to his mouth like it should be. And when it detects something, it'll turn back. I can use that for the TableBot. I can use that for the FloorBot challenge. Excuse me a moment, I'm trying to get these robots here lined up, and we'll have some audio, and then we'll have a little performance piece for you. Well, I'm trying to move my computer and get it on YouTube. could actually play on Does anybody have a computer connected to the network? Is that affirmative?
Mine's connected, and it's already hooked up.
Ah, awesome. You're awesome. Chris Mayer, ladies and gentlemen. Walk like a man. Wow, this will be great, folks. Just wait a moment. This is really going to be worth it. John and John, where are you? Yes, we're going there. It's Halloween, folks. This is the, I hereby declare, thank you very much. I hereby declare Halloween is the roboticist holiday. And yes, I'm trying to get some audio. How's that audio coming, Austin? How's the pro? How much room do I have? We got the room we got right there. Let's move this back. You have a lot of people. That's true. Don't worry about it. Don't worry about it. Yeah. It's the pantry thing. The call works. Hang on a sec, don't panic. All right, this is the black mask dancers here, ladies and gentlemen. Let's hang on a second here. Come out here. Yeah, that's fine. You're good. I got this note here. All right, folks, I love this time of year. In these stores, there's so much animatronics, and there's so much cool stuff. And the best part of it is after the holiday, it's all like half price. And so Halloween comes every year. You know, put some time, energy, and effort into making something fun, robotic. I mean, here's an inexpensive party store skeleton, 40 bucks. Got 4 servos, flopping his arms around. I've got him on a little base. You know, he drives around. And, you know, he's like, I've had him for like 4 years, and it's a ton of fun chasing kids down the street and all kinds of stuff. So it's really nice. So without any further ado, here's the Black Mask Dancers and Monster Mash. Hit it, Oz. America has challenge. All right. So, any more run what you run? Yellow, come on down. Yellow with a quick demo. Imagine that. 1962. Boris and the Crypt Kickers.
somebody.
Yeah. Classic.
Like that? Okay. And then this goes like that. Okay. So let's see if this is here. So, okay. There we go. There we go. Okay. So I was actually haven't had a lot of time to work on this since the last meeting, and I was trying to think of like what would be a cool demo. Okay, so actually I did do some more. I upgraded this to Hydro. So it's still being alone, but it's running Ubuntu. It's running Raring and Hydro. So I ported all my code over to Hydro. That actually wasn't all that hard. It kind of very transparent, went pretty easily. If you have a beagle bone, like a white or a black, or if you have a beagle board or something like that, if you have an ARM board, and you have ROS on it, go ahead and upgrade to Hydro. Pretty much everything works. There's packages for a lot of things. Like Robot posting KDF, a lot of stuff that wasn't packaged under Groovy is now packaged. Thank you very much, Austin Hendricks. You don't have to build them from source anymore. So I'm trying to think of like what I can do that would be a neat demo for me. And it turns out I've had this thing laying around for a while, for about a year or so. I got this little Bluetooth joystick that you're supposed to use with your cell phone for like cell phone meetings. I don't know why you want to use the joystick with the cell phone. But I got it at Hackathon, it was free, and it's been kind of sitting around, and I was like, well, hey, you know what? There's like a Bluetooth stack in ROS, and all of the joysticks use Bluetooth, like for the Xbox controllers and some of the other controllers that we use at Willow, or Suitable, or whatever. Everything for the TR2 is Bluetooth. So, hey, this is Bluetooth. It should be pretty easy. One of the things that I got by upgrading to Raring was when I recompiled the kernel, I was able to recompile it with some Bluetooth flags set the right way so that now I get Bluetooth on my beagle bone. So I have a Bluetooth joystick. This is a ROS drive as the joystick using the joystick driver to control my robot. So I mean, it's pretty simple. It does the cardinal directions, and you have have an e-stop button for it, and it goes backwards, and it turns left and right. And so on the surface, it's not really all that impressive, but it is running ROS. It's using the joystick library. I'm going to need to code up on GitHub as soon as I get it more solidified. And to be perfectly honest, this is actually the one reason I did this is I really like this thing. It's kind of cheesy in a way, but it's really cool because it like fits in your pocket, and you don't have to have like this big, you don't have to like two-handle it with an Xbox controller and big Alt Shift Mega left, up, down, left, right, and then try to use the joysticks. Which is one thing I like, is because I can just kind of like do this and do this, and it's not all that difficult. What? Control, if the robot gets away, it stops. So I have some other code working
laser that does object recognition. I got the math done last night to tell boxes from cylindrical objects. I didn't get it integrated into my main program after the meeting, but hopefully for the next meeting. And that's pretty lightweight. I'll probably have to go back to take out when I'm done too. That's pretty much about it. Come talk to me after the meeting. Thanks.
Thank you very much, Bob. Let's say, robot would be alone, you know, running Ross. This is a new associate of mine that arrived, Chuck Pitzer, with his TableBot. Tell us about Chuck.
So, like Cam said, I'm pretty new to the area. I've been here for about a week. I just came in from Los Angeles. And from, if any of you remember, there was a show a couple years back, probably about 12 years ago, BattleBots. Anyways, I had lots of hardware from BattleBots, and most guys, it just ends up sitting there, you know, it's just, they don't repurpose it for anything. So what I ended up doing is I had a couple opportunities. One was, I had a TV show that I actually wanted to rent one about a year ago. It was on Lab Rats, Disney's Lab Rats. I don't know if you guys have any kids that watch that. But then also I had another chance to use this hardware for Lenovo. And you could move if you want, that's fine. But they wanted to do fighting robots again, so I couldn't say no. So anyways, what they wanted was to be able to do a touchscreen controlled fighting robot competition. So what we ended up with was, I took what we already had, which was an RC-controlled robot, and then I took a BeagleBoard XM, an Arduino to offload some of the sensors and the PWM outputs, and then we did a Wi-Fi control. Pretty straightforward. I'm more of a mechanical guy. I kind of think of myself as like a compulsive mechanical designer. So I understood the hardware, I kind of understand the system, and I work with some guys that do a lot of the software, which you're about to see. So, actually, if Cam, you want to just hold this for a second.
Of course, I just have a standard spectrum of 3.4 gigahertz. Here, let's see how we okay. So let me just show it. Running about half voltage right now. Otherwise, it's really cool. And what you're seeing there with the flashing light is just booted up. The BeagleBoard XM just booted up. So we know that we got control power. So this is just like a standard control. And then now I'm going to hand over control to the touchscreen. And I'll show you why this is important a little later. Whatever the case, it's really good for prototyping because you never know what you're going to get sometimes when you're trying to do computer control. So in a second here you got first-person video, you got the camera on board, and then I should have at least something resembling control. Controlling the arm. Yeah, it's a little skittish.
Scary.
Okay, switching back. So anyways, maybe switching back. Okay, whatever the case, demos of the word. But this isn't the real point. I want to say a little more, okay? Because actually I come
from a hardware background. I'm a mechanical guy. And I understand some software, but not enough to be dangerous. So the idea is that the brain that actually goes in there is a plug-and-play brain. And what we can do with that, essentially, instead of me having to develop hardware and software and do all the electronics and everything, why not just have something more or less like this? Essentially, has an Arduino to offload all the essentially all the inputs and outputs. It'll do all the PWMs for us. It'll take in all my, I just have a breakbeam, encoder that I work with, just a little magnetometer, and then all the graphics processing and video and everything else is traveling through the V4XM. So what I can do as a mechanical developer is I understand all the RC, I understand motors, I understand motor controllers, I understand the hardware aspect of it. And then I can go in here into this little multiplexer that I have here. I don't know if you guys have ever worked with a Pololu. And they have those little multiplexers you can use. And you can swap in and out whether you want to use the RC control or whether you want to use the computer's control, as I demonstrated for obvious reasons. You can kind of skittish. But I can go in and if you program some generic behaviors, like something just to do tracking, something to shoot video or something else. It's a lot easier for a guy like me who's pretty good at building a robot to integrate something that has a little intelligence. Thanks.
Surprise, ladies and gentlemen. Thank you very much. All right. I think Patrick Douglas coming up with the fire robot, right? Do we have any other FloorBots this evening? Any more like what you brought? Any more robots? Last call. Hey, Jared and Andrew, do you want to show your robot? Yes, of course you do. Patrick, I think you might take the FloorBot challenge this year. Logo goes down. And I changed smartphones, and I was having so much fun with loco mode and remote control, making maps, learning to navigate, and it's funny. I can ping each other, and I've traded for different networks, changing the master and the host, and I've worked on different networks in ROS, but this time I've got the IP numbers for the master and the host, and they're pinging each other, but for some reason when I try to run the node, it won't connect. Alan nods sympathetically. Regardless, that's my story. That's my story this evening, and I'm sticking to it. Which hand of the other goes for the oh, you're gonna kill me here. It's the short one on the flat side, right? Okay, that would be ground. So the long one's positive. Sorry about that, Andrew. Tell us about your robot.
Alright, not much physically has changed since last month. To hold the robot, try to fix the robot for the Trinity firefighting competition, where there are 4 rooms that are about 1 foot by 1 foot, and inside one of those rooms is where the is a candle, and you have to navigate and find the candle. So for that, I'm using a polymer drive, 4 optic wheels, right angles, and a Eagle LiDAR. Interfaced serially with a packet board, and this is also going over serial to Arduino Mega and a DAC forward controller, and that's all basically stayed the same. The big thing that's happened is that I've programmed a subroutine that will allow me to input an angle, and it will go on that angle without ever turning. So that's pretty cool. Just to be down. I haven't really got it working.
Andrew, Jared, just want to say I really appreciate you bringing your robot in. It's hard to bring a robot in when it's not running. but all of us, you know, need to show our robots and talk about them and where we're going. I know an awful lot of people put a lot of time, energy, and effort into robots, and bad stuff happened at the last minute, and you couldn't bring it, or you didn't bring it. But anyways, it's all about sharing our robot stuff. Are there any more robots to show? Patrick's showing his. I think Patrick's the only one with an official FloorBot entry here. Tim Craig? Where's Tim Craig? There he is. Master of Ceremonies of FloorBot Challenge. Tim Craig, ladies and gentlemen.
You need to come on.
Call it something on his side. There we go.
Okay, this is our FloorBot phase. This gives the big robots a chance to show off their stuff. Basically, they're too heavy to lift on a table.
Testing, 1, 2, 3. All right, so this is barely any different than last meeting where we had a challenge. And but I did review the video for the last challenge, and I learned two things. One is that Cam said that this can count as an object.
It's an object for purposes of the FloorBot
For
challenge.
the purposes of the FloorBot challenge.
Well, it's like all the other challenges. You make your rules and you go.
There we go. So,
An object is an object.
so the question is, can my robot find an object? And the second thing I noticed from the video from last week is I talked way too much. So all I'm going to do is demonstrate this. As you can see, Pi is tracking this fiducial, and the little twist is that if I hide it, it will go into a very simple search mode, and then the question is, if I move, can he find an object, which in this case is a fiducial? And so he did. There you go. Thank you.
The only rules to the FloorBot challenge are you can't kill or maim any humans, and you can't damage any Google property. Other than that, it's wide open. We have a set of visual pylons I've been dragging here for 2 years worth of challenges, and so far no one has used. So it would be nice someday someone runs a maze of pylons. A nice pink and green one, so the easiest for your vision system to spot. Okay, Ken?
I want to thank everybody who came out and participated and everybody that came out. This concludes our 11th annual HPRC Challenge Phase 3. Next month, Unbounded Robotics will be doing the presentation, and hope to see you then. Have a good evening.